And so when did you kind of get your first introduction to kind of the 3D printing, the additive manufacturing as we think about it today versus the kind of traditional welding?
So I was at Honeywell, and we were on a new engine program, and there's a component that we just nicknamed the TOBI, T-O-B-I, which really is a tangential onboard injector. So when you're running air through a compressor, you're swirling it, but if you hit the combustor with swirling air, you blow the flame out. So you want to take that swirling air and straighten it out so that it hits the compressor. And we worked for a year to get these cast parts. And when we modeled our cast parts, they had 5% more flow than the CFD model said they should have. And so the turbine engineers were just having a fit. And we needed a new one. Well, that meant we need a new core die. And the casting house, we white light inspected this part to death. And the hats off to the casting house, they made it exactly to CAD file. It was perfect. It was the CFD model that was wrong. And so that same week, I was in a meeting with this guy named Greg Morris out of Morris Technologies in Cincinnati, Ohio. And this was prior to GE buying them. So this is like 2008. And I said to the team, because if we didn't have these TOBIs, the right TOBIs, this testing schedule is going to get pushed back a year, which that is never good. That is not good, especially when you've got 100 engineers on the program, right? You're going to let all these guys go. They're going to go to different programs, and you're not getting them back. So I contacted Greg, and we printed 8 of them in the next 4 weeks. And we kind of did a DOE, really, in that we printed, we knew the cast parts was letting in too much air. So we just started sizing them back, right? And then we found 3 of them, right? They matched the CFD model, but not the CAD model. But, you know, that was the saving grace, right? That's how we introduced metal printing to Honeywell Aerospace. And it saved a multi-million-dollar, really $100 million program. Just those 8 parts.
And so at this time, were you constrained at all by kind of the available materials, or kind of the,
No,
like, what were the constraints?
We knew it was 718. We knew it was 718. Okay. And it was risk, really, right? I mean, we made a few tensile specimens. We did a few metallography looks, but our back was to the wall. Either you get a TOBI in that engine in 2 months, or we let everybody go. Because if you get knocked out of Q, there's 5, 6, 7 other engine programs ready to go in your spot into those testing cells. So do or die, print it or go home. And that's what we did.